Now see this, reflexive and irreflexive relations. So I'm talking about irreflexive here. A relation capital R on a set capital A is called irreflexive if x is not related to x, that is x is not related to x through R for all x belongs to A, that is the ordered pair x comma x does not belong to R for all x belong to A. See, in simple words, if I have to tell you, there should not be any diagonal element present in a relation, then such a relation is called irreflexive relation. So if you have any relation, there should not be any element of type 1 comma 1, 2 comma 2 or 3 comma 3, nothing like that. Even if 1 is present, then it is called it is not called irreflexive. Okay, so generally people think that if a relation is not reflexive, then it is irreflexive, but it is wrong. So I'll just tell you the difference. See this, let's take an example, that way it will be easy for me. Let us say A equal to 1 2 3, right? Now if I say R1 equal to 1 1 2 2 3 3, then we know that this is reflexive, right? R2 equal to empty set, we know that it is not reflexive, isn't it? It is not reflexive, and moreover it is irreflexive. Why is it irreflexive? Because no element is present in this set of type x comma x, right? Now let us say R3 equal to 1 comma 1, that's it. A equal to 1 2 3 and R3 is a relation which is a subset of A cross A. Now R3 equal to 1 comma 1, what can you say about it? This is definitely not reflexive. Why is it not reflexive? Because all the diagonal elements are not present. What are the diagonal elements? 1 1 2 2 3 3, all of them are not present, therefore it is not reflexive. And one interesting thing is it is not irreflexive, which means there can be some relations which may not be reflexive as well as they are neither reflexive nor irreflexive. Why? See this, now even if you have at least one diagonal element present, then that relation cannot be irreflexive. Got it? So you have to understand the difference. If all the diagonal elements are present, then only a relation can be reflexive. If no diagonal elements are present, then it can be irreflexive, but it cannot be reflexive. Let me give you one more example here. Let us say R4 equal to 1 2 2 1. What can you say about it? It is definitely not reflexive, right? And what can you say about irreflexive? Is it irreflexive? Yes, it is irreflexive because no diagonal element is present. Now I think using these examples you can find out the difference between reflexive and irreflexive relations. See this one, the first one is reflexive. Why? It contains all the diagonal elements, right? And it is not irreflexive. Why? Because it contains at least one diagonal element. Now the second one is not reflexive. Why? It does not contain any of the diagonal elements. It does not contain all the diagonal elements, that is why it is not reflexive. But then it is irreflexive because it does not contain any of the diagonal elements. R3, if you look at R3, it is not reflexive. The reason is it does not contain all the diagonal elements, but then it is not irreflexive also. Why is it not irreflexive? Because it contains at least one diagonal element. Now if you look at R4, it is not reflexive. Why? Because it does not contain all the diagonal elements, but then it is irreflexive. Why? Because it does not contain at least one diagonal element. I hope you got the difference now. So now one interesting thing about this is you cannot find any relation which is both reflexive and irreflexive. So try to understand this. There can be no relation which is reflexive and irreflexive. Why is that so? If a relation has to be reflexive, then it should contain all the diagonal elements. Now once it contains at least one diagonal element, it cannot be irreflexive. Therefore there cannot be any relation which is both reflexive as well as irreflexive. That is interesting point. And the second point is, there will be some relations which are neither reflexive nor irreflexive, right? Therefore you cannot say that, let us say, if set S is set of all reflexive relations, then you cannot say that S complement is set of all irreflexive relations. Or if you take set of all relations like this, you cannot say that this is set of all reflexive and this is set of all irreflexive. No. What happens is, there will be some part here. It is set of all reflexive relations, it is set of all irreflexive relations, and then there will be some relations which are neither reflexive nor irreflexive, which means the set of all relations can be partitioned according to these reflexive and irreflexive relations into three classes. One class will be set of all relations which are reflexive, other class will be set of all relations which are irreflexive, and then there will be third part which contains set of all relations which are neither reflexive nor irreflexive. Okay, so now other interesting point here is, what is the smallest relation which is irreflexive? If you see this is the smallest relation which is irreflexive. Why? It is empty set and it does not contain anything, any ordered pair, therefore it does not contain any diagonal element, and so it is irreflexive. So what is the minimum cardinality of a irreflexive set? The minimum cardinality is going to be 0, isn't it? The minimum cardinality, right, or the smallest set, the smallest relation which is irreflexive is going to contain 0 ordered pairs. Now what is the largest relation which is irreflexive? So how can we get it? Now largest relation should be, let us say, R5. Now how to include everything in such a way that, how to include as many ordered pairs as possible in a relation in such a way that it does not lead to a irreflexive relation? Just add everything possible and then remove the elements which will not make it irreflexive. So what do I mean? Let us construct a largest set possible, largest relation possible which is not irreflexive, or which is irreflexive. Okay, so R5 equal to A cross A. It is containing all the elements, right, all the ordered pairs possible, but the problem is this particular relation is not irreflexive. The reason is, if you write A cross A, then all the diagonal elements are also going to be present in R5, and so we cannot say that it is, irreflexive relation. So from this you have to remove all the diagonal elements. What are all the diagonal elements? Right, set of all, let us say, diagonal elements. Right, so in this case what happens is, we are going to get all the elements, and from that elements, if I remove diagonal elements, then I am going to get this. 1 1 is not going to be present, 1 2 2 1, or let me write all the elements. What about A cross A in this example? I hope you are following it. I am trying to find out the largest set which is irreflexive. The smallest set which is irreflexive is going to be null set, and therefore the cardinality is 0. I am talking about the largest set that I can form which is irreflexive. Okay, so see this one. What is the largest set or the largest relation which is irreflexive? So let me write A cross A. So A cross A is going to contain all the elements possible, right? What are all the elements possible? 1 1 1 2 1 3. Similarly 2 1 2 2 2 3. Similarly 3 1 3 2 3 3. Now from this set you try to remove all the diagonal elements. What are the diagonal elements? 1 1 2 2 3 3. Then the remaining set is definitely going to be a relation which is irreflexive relation. Got it? So what do you understand from this? you take set of all ordered pairs possible, and from those set of all ordered pairs you just remove the diagonal elements, then the remaining ordered pairs is going to result in a relation which is irreflexive, right? So the smallest irreflexive relation is going to contain 0 elements, and the largest irreflexive relation, in case if let us talk about this, cardinality of A is n. If A contains n elements, then the cardinality of the largest relation which is irreflexive is going to be n square minus n. So how did I get this? Because the set of all elements possible or ordered pairs possible is going to be n square, isn't it? If A is containing n elements, then how many elements will be present in A cross A? It is going to be n square, and from all these n square elements, or from all this set A cross A, you just remove the diagonal elements. How many diagonal elements will be there? N elements. Therefore the largest set or the largest relation which is irreflexive will contain n square minus n elements. Got it? The smallest one contains 0 elements and the largest one contains n square minus n elements. Now what about the reflexive? We did it, right? In reflexive, the smallest set which is reflexive will contain n elements. Why? All the diagonal elements should be present, and the largest set which is reflexive contains n square elements. By everything can be present, right? A cross A is a reflexive set, but here we have to remove exactly diagonal elements, right? That is why I got the smallest set as 0 elements and the largest set as n square minus n elements. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay, IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.